We're back better than ever. We are still in Chapter 11 and we are still balancing equations. And so let's go ahead and scroll down here. Again, we're trying to show you that you have the exact same numbers of each element on the reactant and product side. And in this next reaction, we have silver nitrate reacting with hydrogen sulfide dissolved in water, so it's aqueous, forming a silver sulfide solid and nitric acid. And so in this case, we're dealing with a couple of polyatomic ions, or actually one polyatomic ion, nitrate. And it's usually easier to balance polyatomic ions keeping them together as a unit, if possible. Here's what we mean. On the reactant side, I have one silver. On the product side, I have two silvers. So I'm going to put a 2 out front. So now I have two silvers on both the reactant and the product side. Now, instead of taking a look at nitrogen as an individual atom, I recognize that NO3 is nitrate. And if I look on the product side, I also have NO3 as nitrate, and so I'm just going to balance it as one unit. So I have two total nitrates. If I can imagine having parentheses around this, and there would be a 1 behind that, I have two nitrates on the reactant side. I only have one nitrate on the product side right now, so I'm going to put a 2 out front. Now I have two hydrogens on the product side. If I look, I have two hydrogens on the reactant side, and so my equation is balanced. I have two silvers, two nitrates, two nitrates, two hydrogens, one sulfur, and we're balanced. All right. Going down to the next equation, we have copper chloride and sodium phosphate producing copper 2 phosphate and sodium chloride. I have one copper on the reactant side. I have three coppers on the product side, so I'm going to put a 3 out front. I have 3 times 2 is 6 chlorines on the reactant side. I only have one chlorine on the product side. I'm going to put a 6 in front of that NaCl. I now have 6 sodiums on the product side. I have 3 on the reactant side, so I'm going to put a 2 out in front there. Now I have a total of 6 sodiums. And balancing the phosphate PO4 as one unit, I have 2 phosphates on the reactant side. I already have 2 phosphates on the product side, and we're balanced. So I need 3 units of CuCl2 to react with 2 units of Na3PO4 to produce 1 Cu3PO4 in parentheses 2 and 6 NaCls. And the last one, at least on this page, is the combustion of ammonia. And in this example, I want to show you that oftentimes you have to use a little trial and error to balance the equations. This last one that we're doing, at least at the bottom of the page here, is one of the more difficult ones that you would have to balance in this class. There are some fairly difficult equations to balance, but this one in particular would be as hard as it gets in here. Now, you start off with the nitrogens. You have one nitrogen on the reactant side. You have one nitrogen on the product side. So far, so good. I have 3 hydrogens on the reactant side. I have only 2 hydrogens on the product side. In order to balance that, I'm going to use my strategy of just evening up odd numbers. So I'm going to put a 2 out front. So that gives me a total of 6 hydrogens on the reactant side. And if I have only 2 over here, I'm going to put a 3 out front. That gives me the 6 hydrogens on the product side. Going back, now that I put a 2 out front, I now have 2 nitrogens on the reactant side. So I want to put a 2 in front of the NO2 to balance the nitrogens. And now if I look, I have 2 times 2 is 4 oxygens, plus the 3 times 1 is 3 oxygens there, for a total of 7 oxygens on the reactant side. In order to balance this over here, there's no whole number that I can put out in front here. Some people will start putting fractions out front, and that's okay. What I'm going to tell you to do is I'm just going to tell you to double up and even up odd numbers. So if I double up all of the coefficients that I have right now, I'm going to put this as a 6, this as a 4, this as a 4, And now let me just double check. I have 4 nitrogens, 4 nitrogens. I still have 12 hydrogens here, 12 hydrogens over here. And now if I count out my oxygens, I have 4 times 2 is 8 oxygens here, plus the 6 times 1 gives me 6 oxygens here, so that's a total of 14. So if I put a 7 out in front of that oxygen, that gives me 14 oxygens. So just to rewrite this, I have 4 molecules of ammonia reacting with 7 molecules of oxygen gas, producing 4 molecules of nitrogen dioxide gas and 6 molecules of water vapor. And that would be the balanced equation. So sometimes you do have to do a little bit of finagling to get these things to balance. Trial and error, going back and forth, scratching out numbers is very, very common when you're balancing equations. Alright? Now let's scroll all the way back up to the top here and try a couple more. We never balanced the original reactions that we started with on the top page or on the first page. So let's go ahead and do that. With the rusting of iron, notice I have 1 iron. I have 2 irons on the product side, so I'm going to put a 2 out front. I have 2 oxygens on the reactant side. I have 3 oxygens on the product side, so I'm going to have to double up that odd number because I can't balance those directly. That gives me a total of 6 oxygens on the product side, so I can put a 3 out front there. But now I have 2 times 2 is 4 irons on the reactant side. I'm sorry, on the product side. So I'm going to have to scratch out this 2 and put a 4 out front there. So now I have 4 irons plus 3 oxygens producing 2 iron 3 oxides, Fe2O3. Alright? Take a look at balancing the decomposition of hydrogen peroxide. We have 2 hydrogens, so far so good. 2 oxygens, we have 1 oxygen with the water, plus the 2 oxygens over here. That gives us a total of 3. That's not balanced, so we'll put a 2 out in front of the water to even up the odd number. That gives us a total of 2 times 1 is 2, plus these 2 oxygens over here is a total of 4. If I put a 2 out front, I have a total of 2 times 2 is 4 oxygens there. I have now 2 times 2 is 4 hydrogens on the reactant side, and now I have 2 times 2 is 4 hydrogens on the product side, so that reaction is now balanced. Scrolling down with the methane, 1 carbon on the reactant side, 1 carbon on the product side. 4 hydrogens on the reactant side. I have 2 on the product side, so I'll put a 2 out front there. I have 2 oxygens with CO2. I now have 2 oxygens with the water. That gives me a total of 4. So I need to put a 2 out front. That gives me a total of 4 oxygens. That's pretty much how you need to balance equations. You simply need to go back and forth, plug some numbers in. If you're ever stuck, just put a large number in, a relatively large number in, and start working off that. Alright? If you actually get to a point where you balanced equations with too large of numbers, you can always go back and divide through by the lowest whole number that will divide through by all of them. Let me go ahead and just pause this podcast and explain that a little bit further, how you can balance large numbers using large numbers and then going back and reducing. We'll see in just a few minutes.